Hello again. Coach is back, and now we're going to talk basic algebra. First of all, do not be afraid of letters. When you see a letter in an equation, it is nothing to worry about. It's just taking the place of a number that we don't happen to know yet. Here's the point. You do the same thing with letters that you do with numbers. In fact, if you're having trouble dealing with the letters, stick in some numbers and see what you would do with them. Then put the letters in and do the same thing. Okay, I'm sure you all know how to handle simple equations, but let's just review. If you do the same thing to both sides of an equation, you get a new equation, or at least it looks like a new equation, but the two sides are still equal. Hopefully, it's now in a form that you like better and is easier to solve. Normally, you're trying to get one variable alone on one side of the equation. All right, here are the things you can do to both sides of an equation to get a new equation. You can add, you can subtract, you can multiply, you can divide, you can square, or you can take the square root. To simplify an equation, some terms can be combined, but they have to be the same kind of terms. For example, you can add 3y and 4y to get 7y, and you can combine 2w and negative 3w to get negative w, but you cannot combine 2w and 3y. You can combine more complicated terms, for example, 5pq and 4pq. That gives you 9pq. But you cannot combine 4pq and 16. Okay, when you solve an equation with only one variable, your goal is to get that variable alone on one side of the equation. Let's try it out. Solve this for x. 12x minus 13 equals 7x plus 27. As a general rule, it's best to try to put the variable you want to solve for on the side of the equation where it will be positive. So in this equation, we subtract 7x from each side. We get 5x minus 13 equals 27. Now we can add 13 to each side. We get 5x equals 40. And finally, we divide both sides by 5. And we have x equals 8. Well, that was kind of easy. No parentheses, no exponents. Just add, subtract, and divide. If there are parentheses, then you must deal with them first. After all, P is the first letter of PEMDAS, the order of operations. Okay, the order is this. Parentheses, exponents, multiplication, division, addition, subtraction, in that order. If you can combine terms within parentheses, then you can get rid of the parentheses. For example, let's solve this for x. 2 times 7x minus 3x equals 16. Okay, first we combine the terms inside the parentheses. That gives us a 4x. So it's 2 times 4x equals 16. Now we can multiply 2 times 4x and get 8x equals 16. And of course, you know how to solve this for x. But what if the terms inside the parentheses can't be combined? Then we use the distributive property of multiplication. For example, let's solve this for x. 3 times the quantity 6x minus 7 equals 15. 6x cannot be combined with negative 7, so we have to use the distributive property to get rid of the parentheses. When we use the distributive property, we simply multiply 3 by each of the terms inside the parentheses separately. Here's what we get. 18x minus 21 equals 15. And you know what to do from here. All right, let's do one more problem involving exponents and square roots. The Pythagorean theorem is often used in triangle problems. If you don't know it, check out the lesson on right triangles. Now let's try this problem. if the legs of a right triangle are 15 and 20, what is the hypotenuse? Well, you know that this is a Pythagorean triplet because you studied geometry, but if you didn't know that, you'd have to calculate. So let's do it. A squared plus b squared equals c squared. A equals 15, b equals 20. So we've got 225 plus 400 equals c squared. That's 625 equals c squared. Now, we can take the square root of both sides of the equation. The square root of anything squared is just the anything. So the square root of c squared is c. The square root of 625 is 25, so we have c equals 25. Now you remember that triplet, right? 15, 20, 25. Okay, one more note. Not only is the square root of anything the anything, but the square of the square root of anything is the anything. These operations are often useful.